Welcome to today's lecture on Pascal's Triangle. My name is Drew Collop. In the previous lecture, we were expanding binomials by placing an exponent on the binomial itself. We looked at very large numbers, and at the end I postulated what would happen if you expanded a value like this. I stated you could do this. It would take a lot of work, however. Thankfully, individuals in the past notice patterns in the mathematics, and from that we can use some of these shortcuts to solve some of these challenging problems. One of those individuals was Pascal. This person was a French mathematician, physicist, and philosopher. Pascal's triangle is named after this individual. That being stated, this was discovered by other cultures independently, some of those discoveries done before Pascal. Let's observe what Pascal's triangle is. In the previous lecture, I was applying the binomial to an exponent. Let's review that. So here, a plus b to the exponent 0, anything raised to the exponent 0 is 1. We have a plus b to the exponent 1, and let's just put the exponents in there. We have a plus b. We have to the 2, we have to the 3, 4, and 5. I'm going to put in the exponents here. And I'm going to put in the coefficients that you don't see. There's a 1 there, there's a 1 there, a 1, 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 and a 1. Now, what these mathematicians discovered was that if you line them up, there's a pattern that comes about. On the outsides of this triangle, we have all 1s. And on the inside, the number on the next level is related to the numbers on the previous level. As an example, 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 2 is 3. 1 plus 3 is 4. 3 plus 3 is 6, 3 plus 1 is 4, and so on and so forth. 5, 4, 6 is 10, 4, 6 is 10, and we have 4 and 1 is 5. Could you guess what the next one is going to be? A plus b raised to the exponent 6. Well, we're going to have 1, a to the 6. We then have plus 1 plus 5 is 6. A, so this goes down by 1, a to the 6 goes a to the 5, and then technically there was a b there, it was just to the exponent 0. This down goes up by 1. On the next level, 5 plus 10 is 15, plus 15, a to the 4, b squared, and then 10 plus 10 is 20, plus 20, a cubed, b cubed, plus 10 plus 5 is 15, 15, a squared, b to the 4, plus 6, a, b to the 5, and finally plus 1, b to the 6. So here you can see Pascal's triangle is a quick way to get the coefficients in front of these variables. Let's draw Pascal's triangle in a bit of an easier method. So we have 1s on the outside of the triangle. And the number in the middle, we add these two up. 1 plus 1 is 2. 2 plus 1 is 3. And 2 plus 1 is 3. Then we have 4, 6, 4, 5, 10, 10, 5. And we can keep going with that. It is easier to work with Pascal's triangle than to try and expand something like a plus b to the exponent 15. That would be a very challenging operation to do. Let's look at a few examples. Example 1. 3x plus 6 to the exponent 3. Here you can see we have one variable and one constant. So how Pascal's triangle works is we look at these two values here. A is equal to, in this case, 3x, and b is equal to, in this case, 6. Let's now draw Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. That's as far as we need to take it. Why? because this value here, in from the 1, represents what the highest exponent will be. So we're going to be dealing with this row of Pascal's triangle, and there should be 4 terms that come out of this. So let's solve this equation. What I'm going to do first, I'm going to write my 3x, and I'm going to write my 6. How I start this, I put the 3, my largest exponent, on the first value, and I put a 0 as the second exponent on the other value. I'm then going to add to it and do the same thing, 3x and 6. I'm going to decrease this exponent by 1. I'm going to increase this exponent by 1. It's 2 and 1. 3x, do the same thing here. 1, 6 squared, plus 3x, 0, 6 cubed. Now what I'm going to do, I'm going to use these values as my coefficients. 1, 3, 3, and 1. And that's how we build that. So the coefficients themselves come from Pascal's triangle. The variables themselves, they come from inside the binomial. And our exponents here, we start with the highest exponent on the first one, and then 0 on the second one, and we slowly decrease the first exponent and increase the last exponent until we have the 3 and the 0. Now our job is to distribute and solve. So notice this cubed is applied both to the x and to the 3. This gives me 1 times 3 cubed is going to be 3 times 3 times 3 is 27x cubed. And anything raised to the exponent 0 is just 1. We have 3. Again, make sure you distribute the squared, not just to the variable, but also to the coefficient. Plus 3, 3x, 36, plus 1. Anything raised to the exponent 0 is 1. 6 cubed is going to be, well, 6 times 6 is 36. 36 times 6 is 216. Now let's work that out. We have 27x cubed for the first term. We have 3 times 9, which is 27, times 6, which is 162. X squared. So this comes from all of this, just as this came from all of this. Let's now combine these together. 3 times 3 is 9, times 36 is 324. X. Lastly now, let's combine these together. Pretty simple. 1 times 1 times 2, 16. 216. There's your final answer right there. This one here, not such a challenge, only exponent 3. It may have been actually faster to do FOIL on the first grouping and then to distribute the 3x plus 6, but we picked an easy one to start with. It's going to get more challenging. Let's try the next one together. So here, it's a bit different now. Here we have 2 variables. In the previous one, we had a variable and a constant. Made it a bit easier. Let's work this one out. Our a value is 4x, and our b value is just y. Let's do Pascal's triangle. Our exponent is a 4, so I have to go up to 4 with Pascal's triangle. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So this is the level we're working with, again, because that is the same value as your exponent. And in this case, there will be 5 terms that come about. 1, 2, 3, 4, 5. Let's work it out now. Here's your 2 values. Here's your a and your b. Here we have 4x. Our exponent was a 4, so we start with a 4. Y to the 0. We're going to leave a gap here. 4x cubed, y to the 1. 4x squared, y squared, plus 4x to the exponent 1, y cubed, plus 4x to the exponent 0, so I'm running out of space, y to the exponent 4. Let's put in our coefficients here now. Our coefficients are 1, 4, 6, 4, 1. Again, it comes from Pascal's triangle. Let's work this out now. This is going to be 4 to the exponent 4, which is going to be 256 x to the 4. Next up, we have all of these. We have to combine all of these together. We have 4 cubed. Remember, this goes not just to the x, but also to the 4. 4 cubed. 4 times 4 is 16, times 4 is 64. X cubed, y. Next up, we have 6. 4 squared is going to be 16x squared, y squared, plus 4x, y cubed. And lastly here, we have this value and this value is just equal to 1, so this is y to the exponent 4. One last line to finish it off. 256 x to the 4. 4 times 64, 256 x cubed y to the 1. Just put y. Plus 16 times 6 is 96 x squared y squared. Plus 4 times 4 is 16 x y cubed. Finally, y to the 4. Final answer, that whole thing right there. So we're able to do this in 3 steps, as long as you understand how Pascal's triangle works. So you can see this is getting a bit more challenging, but it's a lot easier than it would be to do, for instance, 4x plus y times 4x plus y times 4x plus y times 4x plus y. That's what that represents. Instead of doing it in many, many steps, we just did it in 3. For your convenience, I've created a very large Pascal's triangle. Let's look at some aspects of Pascal's triangle. If we look here, you can see on the outside of the triangle, you can see on the outside here, this first row, it's all 1s. On the next row here, these are our counting numbers. 1, 2, 3, 4, 5, 6, so on and so forth. But what it also is, it is the exponent on the binomial that you're raising. There are many interesting patterns to Pascal's triangle. Another interesting one is this. Let's add up the rows. This adds up to 1. This adds up to 2. This adds up to 1 plus 2 plus 1 is 4. This adds up to 1 plus 3 is 4, plus another 3 is 7, plus 1 is 8. The next row, 1, 4, 5, plus 6 is 11, plus 4 is going to be 15, plus 1 is 16. Hopefully you see the pattern here. What's the next number without adding them up? It's 32, and then 64, and then 128, and then 256, and then 512, and then 1024, and then 2048. How am I doing this in my head? I'm doing this in my head because the horizontal sums are 2 to the exponent n, where n is the exponent here. We have 2 to the 0 is 1, 2 to the 1 is 2, 4, 8, 16, 32, 64, 128, 256, 512, so on and so forth. There are other patterns that come about in Pascal's triangle. However, you don't have the knowledge right now to fully comprehend those patterns. And I will not bore you or confuse you with those patterns. You can see the numbers get very large. When we get to the exponent 16, some huge values across the board there. Don't worry, I'm not going to ask you anything quite that large. Let's look at one more variation. Here we have 2 variables, but here one of the variables has a negative sign on it. What do we do with that? Something a bit different. What we do, a in this case is the first value, which is 2x, and b is the second value, but the negative comes along for the ride. Remember that. That negative comes along with it. Don't forget that. Let's build Pascal's triangle. We're going to up to 5 here. So let's build that triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. There you have it. Going up to exponent of 5. We're using this row here. 1, 2, 3, 4, 5, 6 terms you'll get. This one's a bit more challenging. We're including a negative sign. Let's work that out. So this is equal to, we take our first value, put it to our maximum exponent of 5, taking the second value with the negative sign, put it to an exponent 0. And continue to do that, decreasing the first exponent by 1 and increasing the second one by 1. There you have it. How many terms do we have? We have 1, 2, 3, 4, 5, 6 terms. This one starts at exponent 5. This one ends at exponent 5. Now let's put in our coefficients here. 1, 5, 10, 10, 5, and 1. All we have to do now is apply the exponents, multiply those values together within the same term, and simplify. Let's do that now. On the first row here, we get 1, 2 to the exponent 5, 2, 4, 8, 16, 32. 32 x to the 5 times 1. You don't need to put this 1 in. I'm just putting it in there to indicate what I'm doing. I don't want to skip any steps and confuse you. Plus 5. Now we're applying the 4 exponent to both the 2 and the x. So 2, 4, 8, 16. 16x to the 4 minus 3y. We add to that now 10. We apply the cube on the 2x. 2 cubed, 2, 4, 8, x cubed. And now we apply the 2, not just to the y, but also to the minus 3. This is extremely important. Minus 3 times minus 3 is positive 9. Positive. 2 negatives make a positive. Positive 9 y squared. Next up here, we have 10. Apply the squared, 4x squared. And now, again, we have to apply the cube not just to the y, but also to the minus 3. Minus 3 cubed. The minus is in there. Minus 3 times minus 3 is positive 9. Positive 9 times minus 3 is minus 27 y cubed. We then have 5 times 2x. And again, let's apply the 4 to the negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. Negative 27 times negative 3 is positive 81. And then lastly, again, that 5 goes here and on here. So we are up to 81. Now let's multiply by another minus 3. That becomes minus 243 y to the 5. Notice when we had an even exponent, we got a positive value with that minus 3y. When we had an odd exponent, we got a negative value. Very important. That is why the negative sign comes along for the ride. Let's now finish this off. Work this out here. 32x to the 5. Now notice, I'm going to work out this one next. See what's going to happen here? This is going to be now subtract. 5 times 16 is 80, times minus 3 is going to be 240. Minus 240, x to the 4, y to the 1. Add to that now. We're going to combine these together. 8 times 9 is 72, times 10 is 720. 720 x cubed y squared. Let's combine these values together here. Notice the negative sign right here. Put the negative sign in there. 4 times 27 is 108 times 10 is 1080. X squared, y cubed. Combining these together, we're going to get a positive value here. 5 times 2 is 10. 10 times 81 is 810. Lastly here, work this out. Just going to be minus 243 y to the 5. Pretty large expression here. Double check that. Looks good. So notice here we have x to the 5 and then x4, y1, x3, y2, x2, y3, x1, y4, x0, y to the 5. How many terms do we have here? We asked for 6 terms. 1, 2, 3, 4, 5, 6. You can see here this looks quite challenging. However, the alternative is you would have to do this math. That's what that whole thing right here is equal to. So it is a challenge. However, if you notice some patterns, we can use some shortcuts and we can solve these quite simply. Practice problem. Give this one a try. I'm going to write the answer down. I'm not taking it up. If you'd like me to take it up, I can take it up during tutorial, but I'll write the answer down. It is quite large. If you can do this, any questions I ask you on the quiz and test won't be a problem. So make sure you get this done. In today's lecture, we looked at what's called Pascal's Triangle. It is a pattern that exists when we're applying an exponent on a binomial. We can either expand it out manually, or we can use Pascal's Triangle to find the coefficients that come in front of each of the terms in the expansion. If you're dealing with a very low exponent, it can be a bit quicker, but maybe not so much. However, when you're dealing with very large exponents, unless you're a computer, there's no other way. This was quite a useful technique back in history. However, now we have computers, and most of this can be done in a very short period of time. However, we are training your brain to think logically and observe patterns. So please don't take shortcuts and use a computer for this. Please do this by hand using Pascal's Triangle. That's all for today. Until next time.